This is probably a familiar object, but not normally seen in this form. It's a joystick from a games controller, and in this video we will find out how to connect it to the Arduino and how we can write software to use it in our projects. Here we're going to dive in straight away to get some first-hand experience playing with this joystick. If you need further details about how the electronics works or how to make connections using the breadboard, please click on the on-screen links now. If you've used a games controller fitted with this device, you will know that the system reacts as you move the knob around. It also responds like a switch when you press the joystick down. If you examine the underside of the joystick more closely, you will see it's actually connected to two small devices, here and here, that are like small volume control knobs. One senses just the up and down movement, and the other one the side to side movement. It's when the signals from the two devices are combined that you know exactly where the joystick is. A third micro switch clicks when the button is pressed. As in the previous videos, we will look first at the hardware connections and then the software used to deal with this device. We already have a Raspberry Pi fully connected to a keyboard, mouse, screen, network and power supply, but the supply has not yet been switched on. As this is the B+ version of the Pi, we can use the additional USB port to connect directly to the Uno. You will need a USB hub if you are using an early version of the Pi. There's no need to connect the power supply to the Arduino itself, as all of its power is supplied via the USB connection. Inspecting the joystick, you should see that pins have already been soldered on the board, and these have been labelled ground, +5V, VRX, VRY and SW. Ground and +5 volts are the supply to the board, and VRX and VRY are the signals from the joystick. SW is connected to the switch. We now need to connect these pins to the Arduino. One method that avoids soldering is to use a breadboard. The joystick is pressed firmly home into place and small connecting wires inserted and mapped across onto the Uno. It's conventional to use black wires for ground connections and red for +5 volt supplies. The other colours don't matter. I've selected blue for VRX, yellow for VRY and green for SW. On the Uno, black again goes to one of the ground pins and red to +5V. This now leaves only the blue, yellow and green wires. Where should these be connected? Three reasons for selecting this joystick as the first device to be connected to the Uno on this course were: first, it's a familiar and useful control device; the second is it's incredibly cheap; and third, it's an example of both an analog and a digital device. Remembering back to the first video, we saw that a light switch is a digital device, on or off, and a dimmer is an analog device, on, off and all the values in between. The joystick switch connection, SW, is digital, and the other two connections are analog. The Uno has special pins for analog inputs. They are here labelled A0 to A5. All 6 inputs are the same. Note that there are 6 inputs. It's a feature of computing that counting starts at 0 and not 1 as you may be used to in the real world. I've chosen A0 input for the blue wire and A1 for the yellow wire. On the other side of the board are the digital inputs. The white labels number and describe the pins. The first two, 0 and 1, are marked TX and RX. We cannot use these as they are used by the Uno to talk to other devices. They are also connected to the two yellow LEDs seen in the previous video that flash on the board when the sketch is being uploaded. So let's avoid these and use the next available pin, pin 2. In goes the green wire. This completes all of the hardware setup. Let's now move on to the software. Open the Arduino IDE by clicking on Start, Electronics, Arduino IDE. If it's already open and you want to save your previous work, then either press the down button here or use the File Save or Save As options here. Click this New button to start a new script. Here we begin writing our code for the first time, and I'm going to give away a few basic secrets of coding. The first secret is that we are starting with a blank sketch, and that is very rare because most code is not new. It's been copied or reused from elsewhere. It should not be too long before you realise this and shamelessly do it too. Copying or reusing code is good. After all, time is limited. Why reinvent the wheel? If code works elsewhere, use it. New coders like structure, organisation and control. That is why they are coders. So the first thing is to recall two important items from the previous video. 1. The use of helpful comments, and 2. The two parts of every Arduino sketch, the setup and loop. So let's type in some useful comments and structure. Top tip. There are times when writing comments to yourself may seem long-winded, stating the obvious, but it's amazing how quickly details are forgotten. Good documentation can save a lot of time in the future when you return to your program and have forgotten how it works, or which pins were connected where, or how or what your program does. So comment generously. Now the comments are in place, and to confirm, the text editor has coloured them grey. Those two empty areas for the setup and void parts of the sketch should be in brown. There is an error normally called a typo if they are not, and needs to be corrected now. This is where we think about what we want our program to do. The requirement here is that we want to read the values of VRX, VRY and SW to find out what they look like, and then send the details back to be printed on the screen. Remember, the Arduino has no screen of its own. It has to transmit it back to the connected device, here the Raspberry Pi. Let's also make the LED pin on pin 13 reflect the status of the switch on the joystick. Now the analog inputs are especially dedicated and marked as inputs. We do not need to tell the Arduino anything about them, as they are already set up. The digital ports do need to be described, as they can be set up as inputs or outputs. So, in the setup, add the lines. Pin mode 2, input, semicolon. Notice the camel case and the input in capitals. Pin mode 13, output, semicolon, output in capitals. This sets pin 2 digital pin to an input and pin 13 as an output. Now there is a slight modification to the input command that's fully covered in the electronics section. For the moment, just accept the change of the input parameter to input_pullup on pin 2. We will also cover this in a later video. Please accept it for the moment. We saw earlier that digital pins 0 and 1 are also marked TX and RX for connection to the Pi. We now need to tell the software that we need to set up these pins so that the results can be sent back to the Pi. Luckily, a lot of work has already been done for us. All we need to do is to tell the Uno what speed it needs to talk to the Pi. Again, this chat between the Pi and the Uno is covered much more fully in another video. In setup, all we need to enter is serial.begin 9600, semicolon. Note the capital S in serial. The editor leaves it in black to warn you if you've missed it. 9600 is known as the default setting that is supplied as standard. There's no need to change this. This completes the setup section. Now let's move to the loop. In the software, we can give names to the readings we take. It's another way of making our code easier to understand. So, to read the two analog ports, we say x equals analog read, open brackets A0, close brackets, semicolon, and int y equals analog read, open brackets A1, close brackets, semicolon. Int is short for integer, which is a quick way of telling the computer to expect a whole number, like 3, 5, 17, 1000, and not 3.6 or 8.244. Again, just accept this for the moment. I just want to quickly get you familiar with the working system, and we'll correct and cover this part in the next section. Serial print line, yes, that's an L and not a 1, prints out the value in the brackets. The command to read the digital pin is similar to the analog one. Instead of analog read, it's digital read. Note the camel case again. Let's call the digital value Z. So, int Z equals digital read, open brackets 2, close brackets, semicolon. Read the digital value from pin 2. Serial print line Z is, unsurprisingly, the command line to print Z on a line. To send the digital value on the button to the LED on pin 13 that we flashed in the previous video, digital write, open brackets 13, Z, close brackets, semicolon. I suppose we could write this as digital write where what, which in this case is Z to 13. Note the order in digital write. Finally, to give us time to read the screen, add a 1 second delay to stabilise things. As all of these commands are in the loop area, they will repeat continuously until the Uno is turned off. Now may be a good time to save. Press the save button to save your sketch. Another top tip, give your program a short but meaningful name. It'll help you find it in the future. Let's put this all together. Switch on the power to the Pi. If there's no large bang or smoke, compile and upload by pressing the upload key. Check for errors in this pane. Watch the progress in the progress bar and watch the LEDs flash as the Pi and the Uno talk, transferring the code. Little appears to be happening. To see what the Uno is sending back, we need to click on Tools, serial monitor. Or, as the shortcut mentions here, just hold down the Control and Shift button and press M. If all is well, a further terminal window opens with the data from the UNO. The monitor displays over and over again, every second, the X and the Y values, followed by the digital 0 or 1, which is the value for Z. Is this what was expected? What range of values are printed for the full movement of the joystick up and down and left to right? Check the button press on the screen, 1 and 0 when pressed, and whether the pin 13 LED is turning on and off too. It does, good. All appears to be working. How easy can this be? In future, we will see how using a monitor like this to display what's happening in the program is a great tool for checking out what is happening or what has gone wrong. This is called debugging a program. We saw how to use a breadboard to connect the joystick to the Arduino. We can now read analog values as we did from the analog ports A0 and A1, read digital values as we did from pin 2, and write a digital value as we did to pin 13. We also learned how to print lines of information to the monitor screen using the serial print line function. Before we conclude, I'd like to cover nesting. Not that type of nesting. Nesting in terms of software and how it works like this. At the moment, the loop part of the sketch reads easily. 3 lines of read for X, Y and Z, followed by 3 lines of serial write. A digital write to the pin 13 LED and a delay to make it all slow down so that we can see what's going on. Some coders like to further condense their code into a smaller size. This can be useful but can make programs more difficult to understand. See what you think. It works like this. The serial print line function prints X, and X is analog read A0. So let's replace X in the serial print line by dropping it directly into the print statement. Let's do the same with Y and Z, opening up the brackets and dropping their definitions directly into the print statement. Shorter code or more complex? You decide if nesting like this is a good idea. Next. In the next video, we'll control a servo.